So in this session, we were continuing the same topic, that is the revision of the slides. So if you look at here, the subroutine, okay, subroutines are mainly used for local modularization purpose. Even local class through also, you can achieve the same functionality. Yes. Okay, local class, local subroutine. Global modularization is possible by using global classes and function groups. That is our next topic. So if you declare some data within method and method within function model, program cannot call, because the advantage is that data is protected. That is the main purpose. Okay, you can export import in this way. That is next. So now current topic is subroutine. So if you consider simple example of subroutine, okay, this is your example of subroutine. Write underscore list, write underscore list. Two times you are calling main program subroutine. Above perform statement written below is a subroutine definition. So write list of airlines, skip statement, write statement, LH for Lufthansa, AA for American Airlines, EA for United Airlines. Again skip, provide blank lines and underline. That's it. So two times you will get the same output. Yes, simple, no need to explain further, because that is about your basic introduction. Then move on to the next topic is this. Passing, parameter passing. Parameter passing is nothing but visibility of the global variables, right? See here, global variables are the global declarations. In fact, if you want me to tell, is global variable name, okay, name begins with the GV underscore. Similar, local variable name begins with LV underscore. Okay. Next, global work area. Global work area begins with the GW underscore, GWA underscore, like that. So this is your RGS underscore, global structure. Okay, global structure. If you go to here, same local work area or LWA underscore, or local structure begins with the LS underscore. Okay, this is your global structure, right? So nomenclature, naming conventions, we have to follow like this. I tab, yes. So global internal table name begins with GT underscore. Okay, or somebody writes G IT underscore also. Yes, this way they can go with this. So now when it comes to local internal table name begins with LT underscore or LIT underscore, etc. Okay. So even you can declare local constant and global constants. Not only that, so global constant name begins with GC underscore, and local constant, because it is one time discussion. Tomorrow it will be useful when function and function, method and method between also we are going to use, yes, LC underscore. Yes, global flag. Hmm. Global flag is flag, FLG. Flag begins with GFLG, FLG underscore, like that. Underscore followed by your own name. Okay. FL underscore also they will write. Local flag. Okay. Begins with LFLG underscore. So this is your overall. Okay. Mm. Yes. Okay. A type I, B type I. Call subroutine, call subroutine. So you can use AB directly in the subroutine also, but generally that is not recommended. That is using of the and global declarations directly within subroutine generally is not recommended. That's why we'll go with alternative formal parameters. That is your A type I, B type I, because this nomenclature, once again, I am going to cover as a separate topic in the coding standards. Just for the time being, you remember this, okay? Because we will use these things now onwards. So, A, B, C, D all considered as a global variables. Now, call subroutine. See, you have to remember there is no such keyword called as call subroutine. Call function is there, call method is there. But call subroutine is nothing but a perform statement. So, perform statement with A comma B. Okay. Yes, this is a general this thing. So you can write A, B. Alternative for A equals to F1, B equals to F2. That is, this is called as a local interface. So what is that? A subroutine. Okay. Yes. You have to consider, yes, what is the meaning of interface. Hmm. Subroutine can be declared with local interface. Interface. That is all formal parameters declared along with form statement is called as local interface. So what is the meaning? Yes, in fact, local interface mm, is optional. That is, local interface, that means it is optional. And that too, local interface is but local declaration. Local interface differs uh, from subroutine to subroutine. That is one subroutine to another subroutine, it differs always. It is not common. Yes. Okay, clear? So, that is why when you go to this, you have to write optional addition. Optional addition means it is not mandatory. It is not mandatory. Even for this also, changing whatever you write it, all are totally optional. Using followed by whatever you write it, these are all optional. Mm. Sorry. So optional brackets. Okay. Without this also, this is local because this is applicable to this subroutine only. That's why it is called as a local interface. Then next. Mm. So formal parameters. Interface. So here you can use AB global declarations directly in the local also, but that is too fixed. More flexibility is declare formal parameters. Formals through you can perform the similar operation easily with the flexible also. Okay. That is the advantage. Right. So next, if we go to Yes. So different ways of passing interface parameters. ABC, F1, F2, F3. Call subroutine, this is subroutine. A, B, C. So for example, first they have given as a call by value, B call by value and result, C call by reference. That is the way I introduce, the way they introduce is opposite. First, when it is call by value, what happens? Call by value, what happens? This, when you call a subroutine, a copy of A F1 gets created. Copy of A gets created. That is, F1 memory address, A memory address is different. F1 changes, A value doesn't get changed. That's what you have to remember. But B to F2, call by value and return a result. That is nothing but when F2 changes, it will reflect on B also. But at the end of the subroutine, this F2 value will be returned to back to B. Okay. Right. Next, C to F3. Call by reference. Call by reference is nothing but like your call by reference is nothing but pass by reference. Address is same. That is, here we are passing address of actual to formal, so that what happens when formal changes, actual will get reflected immediately. That is about your different ways of passing interface parameters. Right. Okay. So, yes, the value is passed to, yes, form of the variable copy without allowing the subroutine to change the global. So that is the whatever changes you do it, that changes remains local. This is right. Changes will be reflected final value of the copy back to the original. Yes. Here it is directly effect. When formal changes, actual will be changed. That's why I told you, if you want to override the actuals is okay, then go for pass by reference. No, I don't want to go for, I want to protect the originals actuals, go for pass by, go for pass by value, because so that originals will not be changed. Right. Defining and calling subroutines. ABC, ABC. So I already told you. If it is using value means call by value, changing value means call by value and result. So only changing, no value preceding for formal means it is call by reference. So this value keyword, immediate bracket, we have to write it. Only one you can write. Again, you want to write one more value, you have to write once again. So these are all the rules. Okay, all the three already discussed. So you can find XYZ is the subroutine name and ABC are global variables, F1, F2, F3 are local variables. Uh, that is called as parameter interface declared with XYZ form. Okay. Yes. So value keyword we don't find with the perform statement. Yes. Next. Here. Yes. Now generic versus exactly. What is the meaning of that is in SAP ABAP we have two types of data type. That is generic types or specific type. Your integer, float, fact, num-c, character, date, time, these are all fixed data types. That is called as exact data types. Whereas generic data types are there, type any, A, N, Y, any. Any means which is more compatible. Any mostly used in the dynamic programming, which we don't want to declare. We don't know the data type declaration while typing time, while design time. At that time, we'll go for like generic type. So generic data types are nothing but, okay, generic data types are type any, type any, type any. ANY, any is nothing but generic typing. But type I is specific typing. Specific or exact typing. So here one example I will try to give. Suppose what is the difference between exact versus this? We will see types GTY percentage, data GV integer 1, integer 2, GV result type GTY percentage. That is, three variables are declared into 1 into 2 result. Perform calci percentage using changing. So using means we are sending into 1 into 2 value, getting the result value. That is what you have to understand with the perform statement. When it comes to form statement, using means value of, means it is ready to import the value of yes. See now into one formal is PV underscore. So formal parameters, formal parameter interface, yes, variables declared with P underscore also. Formal parameter interface declarations can be done using P underscore O or PV underscore. Because locals is totally data statics and locals keyword, that is different. But here it is, see, standard approach, they are giving it as a PV actual, PV max. PV max is a second formal parameter for GV int 2. So type any. Generally, when you go with the type, see, this is actual is declared with type I, formal is declared with type any. This is danger. You may get type conflict. Type conflict is nothing but data type conflict. Conflict means confusion. So when we pass the value, it may work, it may not work. It may lead to runtime error also. Short dump also. Because GV result is declared with type P decimals too. But here CV underscore PC. So declared with type any. So type any is not recommended. What happens when you perform CVPC equals to some formals through we are calculating? So when CVPC gets changed, get calculated, it will reflect on GV result. That's what the logic is. So if you look at right side, same program, same picture, only the difference is it is formal, it is not formal parameters using changing. These formal parameters, formal parameters means local interface, are declared with exact data type. GV into 1 is type I, PV actual 1 is type I. GV into 2 is type I, PV max is type I. GV result is type P decimals 2, and CVPC is also indirectly type P and decimals 2. Okay, we can make use of these types. Because I told you types is declared as global, it is used by global variable, it is used by local variable also. Formal parameter also. So this is generic types are not recommended, specific types only recommended. Then next, visibility of global and local data. Global means scope is global, valid within program. Formal means local, visible only. Right? Yes, only local visible. Right. Then local auxiliary variables for rounding. Suppose we declare data LVPC type P. Okay. So here it is, because if you go with GTY percentage is nothing but type P decimals too. But the problem is this result when you multiply with 100 and by max, the result can be more than that. That's why we are declaring a local variable with type P length 16 and decimals 1. So local PC through we are capturing the result first, operation result. Then this local value finally sending back to CVPC also. Okay. So local value only will be sent back to this one. Okay. Yes. That's about your overall concept. Now implementation of subroutine call. So drag and drop. You can go for subroutine call can be implemented in this way. Yes, when you drag and drop, automatically it comes with this interface also. Okay, right. So here subroutine and debug. Advantage is you can evaluate like this. Perform calci percentage is nothing but when you go to F6, what happens? F6 is nothing but you are crossing this at a time you are executing the subroutine at a time. F6. Okay. Which is already declared and discussed. Right. So here, yes, you can see the form name. When control goes to subroutine, there's the form name, event name and all. You can find the list where cursor is there at that subroutine name. You can find it in the standard. Yes, here in the standard tab. You can find the name of the subroutine here. Okay, even at the top also you can find the name of the subroutine. Okay, calci percentage. Okay, here and there here. That's it. Okay. So that's about your overall topic. Then we are moving towards the standard this one. Like 1 second. Yes. So macros and includes are over. We'll quickly. Mm. Yes. After includes, we have procedures, right? Procedures are also introduced because I'm just looking for any kind of missing things are there. So now, here it is. Now you are clear with everything. We are about to close this topic. So form space subroutine name. Using these are all considered as a local interface. Using changing. So with value, without value, you can declare it. Type addition, like addition is also okay. Like we used to do it old, nowadays type only. Okay, using change. Right. Now global data and local data. So here we see one example like I will go to here one local server. Let me log in that server so that we can work on this programs quickly directly. So right. So C38. So we have the AVK underscore program, correct? So I'm using only one program for all the kind of demo examples. Right. Here, yes, we will see this. Right. So, subroutines related, subroutines related. Let us go to, yes, the example of global data versus local data. So this is your, yes, another example. Subroutine can access all the global data in the program which are defined in the main program. You therefore do not need to declare a parameter interface, right? Automatically, yes, it is validated. Form header and form, right? For complex operations purpose, global data and local data, we will keep it as separate. So what we will go for? Yes, this is called as local interface. Actually, local interface is a word used with in the subroutine. In the function model, we will use it. Here we are calling it as parameter interface. Parameter interface is the best one. Yes. Okay. So this parameter interface is optional. Parameter interface differs from subroutine to subroutine. Right. Now we'll go back to this one. Yes. Here. Yes. Preventing the global data objects against locals. That is, locals is a keyword to prevent the value of the global data being changed inside the subroutine. That is, locals through you can declare it. Locals followed by field name, because local, this I have not introduced. I introduced data and keyword. This statement may only occurs between form and form. Local keyword is only available under form and form. With local, you can preserve the value of the global objects which cannot be hidden by data declaration inside subroutine. For example, you cannot declare a table work area which is defined by table statement with another table statement inside subroutine. If you want to use the table work area locally, but you can preserve its content, yes, you must call the local call. So this is your one small program. We will copy it. So copy it into our, yes, okay, pretty printer. Yes. So here form tab test 1, tab test 2. Oh, so we'll go to tab test 2 also. Tab test 2 also. Just to come here, where is this one? Enter. Yes. So first SAP program. Okay, this is about your subroutines. So first of all, tables. Tables followed by global table S flight. S flight is the table. S flight is a built-in table. Yes. So tables keyword through we declared the S flight. Yes. So perform tab test. Yes. So S flight is having some data. Yes. This is having 397 records. So perfect. So we will go back. Perform tab test. Perform tab test 2. So form tab test, tab test. Okay. So now first tab test 1. Oh. What happens? You can call this. It will go to A310150. Right inside plain type is A310150. If you write outside, it is writing A310150. Correct? Yes, any doubt? I will comment this perform tab test. We will only check tab test 1. So A310150, 150. Both are clear, right? Yes, you have to analyze it quickly. Tab test 2. Tab test 2 is this. It will call this. So local S flight. There is a global S flight, local S flight. B747500. Now this is local S flight is a, this is global, this is local. Local keyword through, we declared one table. That is, it creates one work area. So this values B747500 is applicable to local only. But what about this result is the question. Outside, inside value is writing outside. In previous case, it was writing outside. But since it is declared by local, you see, because you have to see that is where it is writing the, what is this? It is writing the older value only. Older value means the first subroutine value only it is writing. So best practice I can tell you, you go to the debugging, because what they want to tell you is that local through, yes. So here if you go to back, yes, we are into standard, yes. Now you can see the event PI module, PBO module. But when control comes to subroutine, ABAP and screen stack, yes, subroutine, yes. The form statement came here, form, tab test 1, so and so program. So this is your first subroutine gets executed. So you can see the subroutine at this level and at this level also. Okay. Yes. So now if you go to the locals versus global, yes, this is your go to desktop 3. Globals, S flight. Locals, no S flight, nothing. So only this value plain type and price. So A310 and this is 150. You're right. So it is printing A310 and all. But when it comes to tab test 2, control comes to this one, local S flight. So there is a local S flight is also there. Global S flight, local S flight. So, but here it is not showing. So this value B747 value only applicable to, yes, B747 value is only remains local only when it is there, 500. But when you come out, A310 is there. Because A310 is the global declarations value, which is already filled in the first subroutine call. So the subroutine call result is holding A310, it is printing. Okay, this statement is local effect value is printing. This statement normally tab test 1 result A3. So when it comes to here, A310 is there automatically. That is the local versus global. Local keyword is used to declare, okay, just here it is tables declaration. Similarly, you can declare the other things also. Yes, okay, go back to the next. So the program explanation is given here. Here. Hmm. Local data in the subroutine. Okay. Types and data, L underscore, you can declare it. Yes, this is your one of the example program. You can test it. Because these things, you will get lot of clarity. So double click, paste first, go to this one. Yes. So, oh, types, word type C, data type, word type text, text type word. So now text equals to some value we can print. Perform data set. Perform data set is nothing but types data. So data keyword through we are declaring above value is 1, 2, 1, 2, 3, 4, 5, 6, 10. But whereas this is A, B, C, D, E, F, G, H, I, J, K, right? So if you go to inside, if you test it, yes, see the result. 1, 2, 3, 4, A, B, C, D, and 1, 2, 3, 4. So better we will analyze that debugger mode. So first, if the program written by somebody, best practice always is go to debug mode. So now go to here. So for first text value I assigned to 1, 2, 3, 4, 8, right? Write text. So it is writing. Perform data set. Data set is nothing but, yes, data set is text word type 5. Okay. So that is text type word. That is, you can go to A, B, C, D, first 5 letters only, it will print. Okay. Yes, he will know. So if you go to text, you will get A, B, C, D, first 5 letters. That's it. But when it comes to out, what happens? The outside, it is again printing. This is similar example. Okay, so you have to understand that this variable declared inside data, it holds the value within the subroutine only, A, B, C, D, E. When subroutine ends, the value ends. Then outside, whatever the previous 1, 2, 3, 0 is printing as it is. Right. Okay. Similar example. Right. So data keyword through one more example. Then next. So local one example. Second is data another example. Then next, if you go to, yes, static data, statics keyword. Yes, more or less same example. Yes, till here we will check statics advantage. So go to here. Yes. So pretty printer, right? Perform data set, data test 1, test 1, test 2, right? So this is your form, this is your end form, right? So first, if this is already I have given the statics example, similarly you will get it. So first you go to data keyword, because first one is your data keyword example, second is we'll keep the breakpoint here so that directly you will come to that place. Yes, breakpoint. Go to desktop 3. Yes, observe data test 1. So data f text. F text value is int. So f text, f text, f text. Right? So that is like when subroutine ends, the value ends. Data test value ends. Right? Once again, you are calling the data test 1. Yes, it is init. Init is replaced by 1, 2, 3, 4, 5. Yes, it is writing. So init 1, 2, 3, 4, 5. Init 1, 2, 3, 4, 5 2 times. That's it. But that is data keyword 3. If you declare something, the value is ending here. But whereas subtext 2. Yes. So we have to observe one small information. Yes. Even in your previous declaration also, when you call subroutine statics, the statics declaration, statics n1 type by value 10, that is considered first time subroutine call only. Second time subroutine call, it won't consider that value. Directly the last subroutine call, last value, it will print. Yes. So the statics will be considered as first time subroutine call only. Yes, that's only the hidden. So if you come to here, init value, printing, yes, A, B, C, D, E, printing. Now the f text value is ABCD. That value doesn't end. It will go to the next subsequent call. So next subsequent call, this init will not be considered. Directly it will come to the right statement. It will print ABCDE. You have to see now. See, go to next. Next subsequent call, same subroutine. Directly see, it is not init. It is directly printing ABCD. So that is last operation, last result ABCD is printing. That's it. Okay. So this is one of the example program for data, statics and local. All the three. Right? SAP examples. I have given my own examples. Can find SAP examples also. Explanation is given here. You can refer it. Local field symbols. Field symbols through also you can perform the operation assign, copy, local. So this is we will cover as a separate topic. Separate field symbols through. Okay. Then next, when it comes to parameter interface, using changing. Yes. Okay. Using change. Type addition, like addition. Yes, input parameters that pass by value. Okay. Yes. Output parameters pass value. Right. So if you don't want to continue the subroutine till end for, can terminate at any point of time by using check and exit. Okay. So there are some events involved. That events will cover as a separate topic. You cannot understand these things. Okay. So there are two types of declarations I said, specific or exact types or generic types. See type any. Type any is, it is alternative for any data type. Type CNPX. That is, there are some data types called as C like C. Yes, which is character data types. Okay. Alternatively, type table means it can be standard, sorted, hash. Type any table. Yes. Type index table. Index table is only standard and sorted. Type standard, specific standard table declaration. Type sorted, types only sorted table declaration. Only hash table declaration. Like that, you can declare specific also, generic also. So here, yes, this is one of the example is on subroutine also. Yes. You can perform read statement, form and form between, nothing is there. So read table with the key also. So fully specified type, fully specified is nothing but exact type. Yes. Okay. Complete types also you can call it as. Next, if you go to the assign component is again related to field symbols. Field symbols. Okay. So this is very simple. Okay. You come here. No. Begin offline, end offline. Call 1, call 2, end offline. Yes. Okay. Text. Data text to value XY. Data text to perform demo using text. See this. Right. So program menu execute debugging. You can go to desktop 3, yes, return, yes, come back to here. So now line, line, and as well as text. So perform demo using text. So when it comes to demo, yes, so here it is using P. Okay, using text. So this is what you have to observe. Using followed by actual variable. Text is a actual. Formal is P. So using followed by one, using followed by one. But here structure addition, structure line. That is text also declared with structure line indirectly. Text also value. Yes, this is your text, right? So if you go to here, yes, P of call 1, call 2. Okay, both P call 1 X, P call 2 Y value it is printing. So it is just like declared by line 1. Line is nothing but two variables through it is declared. So two variables. So it is not giving any type conflict. It is just bifurcating X value into this column 1, Y value into this column 2. It is printing. Okay. So this is example program of the, yes, this one, fitting parameters into structures. So using structure addition, structure followed by structure addition. Yes. Generally we use tables using changing, but this is very rarely used case. Structure addition. I never found this, never come across. Tables. Tables are two types, with header line, without header line also. So you can directly tables followed by internal table name, not work area and all. It could be with header or without header. Table name you have to write it here. Okay. Yes. Terminating subroutine, you know that. Form and form between exit. When we use exit, okay, what happens? It never writes right for. Automatically, see if you consider this or form. So because I am showing you all these things this day, it is this particular notes. This is SAP PDF is already provided to you guys. Can go through it. Okay. So now perform terminate. Right end. So this is your terminate is nothing but exit. Yes, exit through you can 1, 2, 3, the end it will write. 1, 2, 3, the end. Because it never writes the 4. The reason is exit. Keyword is used to terminate the subroutine immediately and permanently. After exit, control goes to end form directly. It never write this value. Okay. Next, perform this one. Okay. So here, sorry. Hmm. Yes. So num1, num2, num1, num2 result. RAS. Correct. So num1 equals to 3, num2 equals to 4, perform divide. Yes. Then num1, num2 perform divide. This is divide. Right. This is your. Yes. Now just observe this. So to test this value, don't go this way. First, one by one, you have to test. So num1, first of all, yes. So here it is, num1 equals to 3, num2 equals to 4. So what happened? Num1, num2 changing RES. So that is, it is 3 and 4 will be received, changing R. Check N2 is not equals to 0. Yes, this is a check condition. Then performing, then returning R. It's very simple. So this is obviously 2 and 3. So, 3 by 4 equals to 2. 3 by 4 equals to 0.75. That's it. That is, this is kind of, okay, this is expression writing style. Second one, okay, we will keep the same one, second line, 5, 0. So we are passing 5 here, 0 here. So N1 is 5, N2 is 0. When N2 not equals to 0, okay, not equals to 0, then only it is executing. But uh, it is equal to 0. That means this time it will, yes, it doesn't work at all. See, check second time. Yes, that is, there is no impact of the second subroutine call, because when num2 0, n2 0. When n2 is 0, don't execute this. If it is not equal to 0, then only this code gets executed. This is the way you have to analyze it. Then 2, 3. Num1 is 2, num2 is 3. N1, 2, 3. So 2 by 3 equals to whatever the result comes, it will display the R. So, yes, 2 by 3 equals to 0.67. Right. This is the way you can analyze the built-in program. Yes, SAP given program. Correct? Yes, because check example, exit example are covered in this way. So calling subroutine, yes, naming internal subroutines. Okay. Yes, internal subroutine. This is your same statement. Very simple and easy. Because these are all again basic examples only, which you can understand it very easily. Because so you how to explore also I explain to you. On top of that, any doubts you have, you can reach out to me. The reason is I always recommend, in addition to my own example, you refer SAP example. SAP examples are covered with lot of meaning, lot of one example gives lot of extended clarity. If you have complete knowledge, then only you can analyze it also. It's yes, okay. So there are two subroutine. You add it and out. Correct? Add it and out. So now we will see where is the out. Yes. First we are calling add it internal calling out, sum of so and so. So first best way to call is this. Go with one by one. So now here it is 2 and 4. Add it. So 2 plus 4 equals to 6. So the sum of 2 and 4 is 6. The sum of 2 and 4 is 6. Correct? Simply. Then go to next. 7 and 11. 7 and 11 through we are calling, yes, this one. Perform, add it. So here it is num1, num2, latest value. There is no using changing, but still as per the sequentially it will take 7 plus 11 equals to 18 out. So the sum of 7 and 11 is 18. So interpreter based examples. Because even though you don't You are overwriting the num1, num2 value, right? Systematically. So you have to see first this 1183, 84, then perform. Then after coming end form, then 87, 88 perform. This approach through yes, inside out will be called. So this is the basics. Okay, yes. There is a concept of if found. Actually, I forgot to introduce. If found is also used. If found addition is used to check, yes, includes, yes, yes. If found, oh, addition is used in includes and subroutines. That is, if found is nothing but if subroutine founds, yes, if include or subroutine found, then only it gets executed. Otherwise, no. Because sometimes if it is not found, it won't execute. Yes, that is about your if found concept. So here it is because we are calling found pool, subroutine pool, whether it can found or not. So dynamic concept is there. Within bracket dynamically you can fill the values are also. That is one of the way. Form pool. Okay. Right. Then this is your do two times high index test subroutine 2. Yes. So first time it will call sub 1. Second time subroutine call subroutine 1 and 2. It will print it. This is very simple and easy. Passing parameters to subroutine. See here it is. You can find it perform subroutine using changing. Yes, changing also. Okay, so this is the example program. Once again, you can try this. This is till here it will end. Stored because you cannot analyze directly from this standard SAP. Take it into our control, paste it, and paste it. Come into the previous code. Okay. Come into the previous code. Now go to subroutine data date 1 and string 1 number 1 count 1 perform type test 1 perform type test form text form and end form, right? So this is your, so observe it. Something. So, yes, right. Date 1, string 1, number 1, counter 1. So there are 4. So here it is something different. So we have to check slowly. Okay, what is the problem here? Because one by one, same subroutine call. So using now text, huh? What is this? Oh, okay. So first, okay. So I will check and get back. This seems like confusion. Okay, I'll do it later. Okay. So this is about all subroutine. Another example is there. We'll close. We can also try out a factorial example is there. We'll close tomorrow and we'll continue with function model topic. Okay. Thank you.